So it's a great opportunity to build on the basic skills we started with yesterday. We're going to be talking about how agents communicate. Yesterday was nice. We had agents with rich diversity, with homogeneity, with different space, and give them nice appearance, and it gives them these attributes and have them evolve over time. And we got a long way yesterday. But these people were still solitude. It was atomistic. They weren't interacting with each other. In a way, I'm surprised the sociologists survive today. We want to take squarely on at this moment. Start this up as a separate lecture. We want to take squarely on now at this point how we have people interact within our model. Because after all, many of our models, say model of childhood obesity, children's early life exposures and later life trajectories are disproportionately impacted by their family environment. Right? We know that people affect one another through knowledge, attitudes, and beliefs involving health issues. We know that there's imitative behavior. We know, of course, at the level of pathogens, the pathogens can be spread by contact of one person with another. There's all these different ways in which people's interactions are quite central to the opportunities they have in life and to their health and the evolution of their health state. And we want to be able to accomplish that. We want to be able to capture that. And this morning we're going to be seeing two aspects of this. The ways in which dyads, that people can interact with messages, and further, the ways in which we can knit people together into broader networks that may be persistent, perhaps they're family networks, or social networks, perhaps they're networks associated with kinship or with workplaces. So we're going to be seeing how we can capture those sort of structures and the dynamics associated with them in AnyLogic this morning. Okay. So within AnyLogic, we've already seen state charts, and we saw how state charts could be used to capture people's evolution over time in a discrete fashion amongst a bunch of discrete categories, often categorical in nature. Now, one of the transition types that we may have noted in that context, it's gone now, but is what's called a message type. And we're going to end up taking advantage of that because it reflects the fact that some of the transitions in the state chart can be triggered by interactions particularly with other people. Okay? So within AnyLogic, agents can be coupled together in discrete fashions or continuous fashions. We're going to see models in this week where we have both. Cases where someone's behavior could be discretely affected, but it's going from a state where they are less concerned about safe sex practices to where they're more concerned, or in a continuous fashion, say where their knowledge, attitude, beliefs, the degree of belief about the importance of good nutrition is nudged upwards in a kind of continuous way by contact with other people. So we can capture both discrete and continuous sort of interactions here. We're going to focus today on discrete ones. Someone's beliefs are changed in some sort of very, very distinctive fashion between categories. And the preferred mechanism for doing this in a discrete way is to send messages to one another. The agents send a message to one another to influence one another. And these messages can be accompanied by information of various sorts. So I send you a message which perhaps tells you some content or tells you something about how I'm influencing you or who is influencing you, in this case me. And an agent can send a message to one or more other agents. Often they're sent locally to neighbors within an environment, either neighbors in space or neighbors in a network. So I send to my family network some influence that then shapes their evolution. Now, messages can be handled in many ways in any logic, but one of the most common ways, I'd say by far the most common ways, is through the state chart. So they can trigger a transition in the state chart. Okay. So you have this transition that occurs because you received the message. So I'm in a situation perhaps where I have low understanding of sort of nutrition concerns, and then I'm influenced by someone in my social network, and I acquire a substantive understanding or moderate understanding of these issues. So I make transition then to a state which reflects moderate understanding of nutrition, something along those lines. Moreover, state charts, not only can they consume messages, can they be sort of lead to a reaction to a message, but they can actually trigger messages. They can actually send off a message, and we'll see how that happens. Okay, to do this though, I want to build up a model together. I want to exercise those basic understanding that we built up yesterday and get you comfortable. Okay, so, ladies and gentlemen, let us create a model here. Okay, so this blank screen stands before us. I'd like you to, how do I add a model in here? Anyone? Okay, file new model. Okay, and we're going to call this model, we're going to call it agent interaction. Agent interaction. Okay, I'll call it simple agent interaction for me, just so I can keep track of which ones came out of this this boot camp. Okay, great. So we create a model. Here we have a main class that kind of keeps track of things across the model as a whole in our experiment. And we want to add a person class. So how do we do that? Okay, so we can right-click on the model as a whole and add an agent type, right? That's a good way. And we're going to call it a person. Often I have whole classes where there are many, many vet students, and there we have greater diversity in the organisms depicted. But here it's just a person. So how did I do that? I did right-clicked on this. TAs, prepare for deployment. So I right-clicked on this. I did new and an agent type, and I typed in person there, and I did finish. Okay? So here's our person. Suppose we want to give this person an appearance. Suppose we want to give them a circle appearance. How do we do that? Palette. And then, general. It's actually in the presentation tab here. Presentation tab. Remember, there are these different tabs, and if anyone's not showing, you can add it down there. But here's the presentation tab, and I want to add in an oval. So how do I add it? Drag it. Excellent. Wow. Wow. I'm impressed. This is not a memoryless process. That's good. And I'm going to make it smaller. The exact size is fairly immaterial, but I like to make it so it's roughly 15 in radius, but that's fine. Okay, so we've just added this. Okay, ladies and gentlemen, suppose we were to run this model now, what would we see? Nothing. Why not? Okay, there's no population. How do we create a population? So we've defined personhood, but we haven't said there are any people in this model yet. We define what it means to be a person. Right now, a person consists of a circle. Okay, good. That's a great start. Excellent start. But we haven't defined there actually to be particular people. So how do we define there to be particular people, ladies and gentlemen? Main, because those people are going to live in a population of main, and then what do we do? Drag person over. Okay, good. Wow, you folks are great. Okay, so we drag this person over there, and I called it population. I could type it in immediately, or I could type it down here in the properties window. But there's one more thing we have to press here. What is it? We have to press population of agents, and we'll make a population of 100. That's fine. We learned yesterday we could make this a parameter, population size. We could change that parameter. Oh, sure, let's do that. Let's do that. Okay, I don't like to do a fixed population size. Let's add a parameter. Sure. How do I add a parameter? This may be useful for our purposes. So how do we add a parameter to this? Okay, good. General. Wow, excellent. Man, you folks are, these ain't no 64-pound weakling muscles anymore. This is great. I see Charles Armstrong's in the making. Okay, population size. Okay, so this is what I'm going to do. I went up to this general. TAs, prepare for deployment. Who needs TA help? Okay, TA help. Okay. Thank you, Kurt. First responder. Okay, so go up to palette, general tab, we drag parameter in and we call it population size. What sort of thing is it? Is this population size, is that an integer? An integer? And I'll make it of size 100 initially. And then how do we actually make that the population size? So right now it just says population size, but it doesn't do anything yet. How do I make it actually be the population size? Well, yeah, in the population where it says initial number of agents, we say population size. Okay, and I'm remiss to not tell you to do this earlier, but after we've done that, let's run the model here. Okay, or sorry, build the model. Build it there. How do I build it? I build it with this little thing up here. Okay. Okay. Now what will happen if I run this model? Huh? So mind you, I made the population size have a value of 100 here. Default value of 100. Okay, so how do I run this model? Suppose I want to check it. How do I run it? Sorry? Okay, I could do it with this. Right click on that. And what do I see? I see 100 people in the population. I could go through them. Okay. Good. Okay, so we have a population of that. Suppose we wanted to run a version of this model with larger number of people, say 1,000 people. How would I do that? Sorry? Change the population size. So I'm going to create a new experiment. Let's say, and I'll say big population. So I'll do a new experiment. I just right click on the model, and I do new, and then experiment. And I'm going to call it big population. And the big will be defined by Saskatchewan standards. So I'm going to make it 1,000 people. Okay? Okay, there's, we'll make it 10,000. That's bigger than all but 4 or 5 cities in our province. Okay, 10,000. Okay, let's run that. Okay, I made it 10,000 correct. Yeah. Okay, so we run it, and here's our population. It's 10,000 people. Okay, that's great. So I'm just trying to use some skills. This is going to come in useful. Okay. So ladies and gentlemen, we have a small population, a big population. That's a great start. We have a population here. So how are we going to make them so that they appear at different places? Right now they all appear copies of us. Does anyone remember? Okay. Their location. Where do we set their location? It's in main. It's in main, and it's in the properties of main. We scroll down in main to the properties. So I'm selecting main here, and I'm going to scroll down in the properties until I get down to this thing called environment for other agents, and I'll do a layout type of random. They're going to appear at random places. Is that okay? Okay, let's run it with the regular population, and let's see. So what do? I do this just to make sure it's okay. I right click on it and I do run. And there we go. And we should see something like that. People see that? Okay. Okay. Who needs TA help? The TAs sit ready. The TAs need to deploy to front. The front sector requires attention. Okay. Okay. Who else needs TA help? Okay. TA. The front sector. Okay. Okay. So, ladies and gentlemen, we're now going to undertake something that puts us in a novel situation. Okay. Specifically, we're going to add something we've never added before. All this is review. All done now is review, and I've done that electively for a reason. Now that we're warmed up, we're going to venture into unknown territory we've never crossed into before. And specifically, what we're going to do is we're going to impose a network. We're going to have people connected together. And we're going to connect them together in a way that reflects geographic proximity. People will be connected to people nearby. We know from health sciences studies that imitative behavior has a big impact on people. Having someone nearby who's exercising or someone nearby who's loading up on fries can have an impact on people's eating or physical activity habits. And we're going to be able to capture that physical proximity between individuals and those influences by imposing a network. Okay? By imposing a network. We're going to now use this to impose a network. Okay. Okay, so the way in which we're going to do that, ladies and gentlemen, is we're going to go to main, and it's just in the area where we set the layout type previously. We're going to set a network type, okay? Okay? Okay, who needs professor help? Who needs TA help? Okay? TA resources becoming available. Who needs TA help? Okay? Okay, so we're going to go to main, and we're going to go down, and that same area where we had the layout, we're going to choose a network type called DistanceBased. So how do I do that? I go to main, I scroll down to that same area that we just changed for the so-called random layout of people, and I'm going to do DistanceBased. So this is an environment for other agents. That sets the environment for all agents that live within it. This population, see this population here? We're going to go down and choose network type, distance-based, and the connection range, importantly, is going to be 75, folks. Okay? Connection range 75, okay? So, big picture here, main is setting the environment for the agents that live in it, in this case for the population. We set it to have a random layout for people before. Now we're going to set a distance-based network, connection range 75. What that means is the people in this population are going to be in a network with each other, and a given pair of people, A and B, are going to be connected if and only if they're within 75 units of each other in space. Okay? So it's just going to be a network that exhibits propinquity. It's going to be grouping together. People will be connected if they are close together and not otherwise. So let's go down and run the experiment here. In fact, I'm sorry, I should say one thing because it's not going to be terribly meaningful. We want to actually show their appearance. We can run this, but we won't really see the network unless we do one more thing, ladies and gentlemen. And the TA should prepare for deployment. Okay, so we need to go to person, and we need to set it so their connections are visible. If you go over to person and you scroll up a bit, you'll see this thing called connections, which we've left heretofore unexplained. It's called connections, and we're going to set it so that those connections are visible, okay? And how do we do it, ladies and gentlemen? You click on connection. So I had to open up person. This is something about a person, their connections. We have to, and we scroll up a little bit because it's not immediately visible. And we go to their connections and we scroll down, and down towards the bottom there should be a thing that says draw line connecting agents. See that? And at the cost of a little bit of aesthetic dysfunction, I'm going to actually request that you do it draw on top of agents, just so it's clear. This by suggestion of Winchell, who pointed out that sometimes the connections aren't visible otherwise. So draw on top of agents. So what did I do, folks? I needed to set it so that the network is visible. The network would have been there before, it just would have been invisible. So I wanted to make it visible. To make it visible, you get a person, their connections, you scroll down to the bottom, and you select draw line connecting agent, and you select it to draw on top of agents. Let us, ladies and gentlemen, let us compute now. So first of all, build the model, make sure it's happy, and then run it. And you should see something like this. Do people see that? People see that? Okay. And let's go see the big network. Let's go see the dense network. Let's go see the network. Yes. Yeah. Okay, sure. So why did we create? Why did we create a bigger? Oh, because I want to show some properties about how that changes things. Okay. Yeah. Okay. So I want to, in just a minute, I'll be showing, or a few minutes, I'll be showing some properties. Okay. Okay, folks. So I noticed one thing when we have this really big population. I think it's going to be too crowded for this. I'd like to make a population of size 1,000. So big population will be size 1,000, not size 10,000. Because it's just going to be too crowded to see effectively. So make big population a size 1,000. Okay? Yes. Yes. Okay, that's because those are connections that main is connected to something else. But you don't want that. You don't. Some models could actually have cities connected with each other, so people connected with each other. Like cities being a transportation network, people on a social network. And so you have these connections to be specified at different levels. But in this case, we want the connections to a person display, not just a network. Is that helpful? Okay. Okay. Questions? Okay. Yes. Okay. There's a freak out. Okay. Okay. Is that for big population? This one? Okay. Oh. Okay. Okay. Can I just take a look at the thing? Okay. First thing I do is put this in. Okay, PA, can you check for other needs? So there you go. And I think we'll make it 1,000 rather than 1,000. Okay, ladies and gentlemen, who needs help? I don't need help. Yeah. So let me set this distance space. Yeah. It does clearly different in the sense that anybody within 75 is connected on one line. We'll see later how we can add connections in dynamically. You can craft the network in whatever way you want. But this is one of the built-in ones that's very easy to define. There's about 5 of them we'll be discussing. Is there one that's like probably taking distance from? No, but it'll be quite trivial to make that so in a way. Okay. Question? Question? If 75 is, so each of these, there's some small grids, so they're each 10. So 75 is a distance from. Okay, other questions? Okay. So in this case, ladies and gentlemen, let me rehearse what we did again, just so people are clear. After we built the basic model, we did two key things we've never done before. Key thing one, we went to main, and we went down and we set the network type to be distance-based and set it to be a connection range of 75. What that means, if you consider two people, person A, person B, those people will be connected if and only if they lie within 75 distance of each other. That 75 distance, what do I mean by 75? What's the distance unit? It turns out that this projector, like most projectors, can't really capture it, but there are these, on your screen there should be these broad lines, and then there's some smaller squares. And each of those smaller squares is 10 units wide, 10 units high. It's a square. And so those define, knowing that that's 10, you can get a sense of what 75 is. And then 75 is something like this distance here. And so if two agents lie within that amount of space, they'll be connected, otherwise they won't be connected. This will be one of many network types we examine in the next 2 hours. Okay. Yes? Yeah. Yeah, you can okay, so the basic deal is yesterday, okay, this is a great question. I'd like people to hear this, because this has relevance, I think. So there's two basic ways in any logic that so in general, any logic has a variety of ways of accomplishing similar tasks, okay? There's a couple different ways you can do things. Even in terms of the buttons, you can get the model to run 3 different ways. You can press this button, that button, or that button, okay? And so it is with building models. Any logic attempts to make certain common tasks really easy by providing sort of automation of certain common tasks, but you always have recourse to a more sophisticated way of doing it if you need it, okay? Now, for the most part yesterday, most of our layouts of models, we made use of this mechanism here. We went to main and we set the layout type to be random, and that just placed people willy-nilly over the space in a spatially swapped on type process, so that you know their location was uniformly distributed in X and Y. Okay. So that's useful to do in many cases, and it's very useful for these little toy models we're just building here. However, there are cases where we want a special logic to be captured as to where someone's location is. We don't want to just delegate it to any logic, you know, picking their locations for it, uniformly X and Y. We want to actually have their location be determined by something we care about. Maybe it's data from a database about that particular person. Maybe it's some aspect of their characteristics, like their income, like we saw yesterday, right? Now, when we have this situation, we don't want to simply say, hey, the main class, go set the, you know, this environment for every agent. Instead, we want to say, let's have the environment, let's have the agents set their own location according to their characteristics. So yesterday, what we did is we actually set people's location according to this place. So in the population, we said we want to place the agent not at the animation location as specified by the environment. We want to actually do it at the specified point. So we actually specified a rule specially for them that gave the location here, and then we said in the environment we said that they have a user-defined layout. That's how we did that, and that basically allowed the person to override the dictates of the main class. So instead of saying to main, hey, no thanks, I don't need you to set my location. I'll do it myself. Thank you very much. Actually, it's the population that does. The population is the one who's saying, hey, for you, I'm creating you, and you're going to live here. You're going to live here. You're going to live here. Just as the population sets the characteristics of the agents in terms of their income and sex and that sort of thing, of the agents who live within it, they can set their X and Y location. And it says the main agent. Look, I don't need you doing this for me, okay? I'll set their X and Y locations as I see fit. Does that help with that? Yeah. Okay. So we have that recourse. In fact, there's a third level where each agent, within the agent, you can actually change their X and Y locations as you see fit. And later, probably today, maybe tomorrow, we'll see that with mobility. The agents will be zipping around and they'll be setting their own location as they desire. So these are just conveniences that try to make very quick certain tasks, but ultimately you have total control over where the agents are at the agent level if you want to. Okay? Okay, very good. Any other questions? These are great questions. I welcome. This is one of the most important components of boot camp. Yes, sir. The main tab? Oh, yes. Yeah, I actually answered. She had a question about that. And do you want me to address it, or do you want to address it?
I was offering to do because all the things kind of look the same.
Right.
You see that connection in all of them, you see the circle and all of them. So you know which one is which. Why wouldn't you see the connections in the main?
Okay, this is a very good question. So the answer I get to T was roughly on this level, and I'll repeat it to the time. And so AnyLogic tries to provide a very flexible environment for specifying dynamics in structures like networks for a variety of types of agents. So here we have persons, but we could have had persons in cities, and each of them, there can be persons, they live in cities, and the cities, and persons have a network with each other, and then they live within a city, and cities are in a network with each other. And so you can have a whole hierarchy of kind of different types of people and structures. A network of different at different levels, not just persons. You have persons, and schools can be a network. Neighborhoods could be in a network associated with proximity to each other, and cities in a network. And so, as a regular rule, AnyLogic provides this connection thing for any of these sort of agent types, like main person. Whenever you create an agent type, there's connections provided to it. The key thing you have to realize about that is the semantics of that. That specifies the connections for the thing that includes it. So if it's appearing in a person, it says, this person connected. And we can create many such connections. We'll be doing that eventually at some point in the boot camp. We'll probably see it at some point. So I might have several connections networks. This is just one of them. This is the built-in one. But I could have social connections. I could have needle sharing connections. I could have sexual connections. I could have connections of all different sorts, representing different types of contacts, right? Family connections versus workplace connections. And you can have several of those things for a given agent type. Okay? But the point is that they represent connections of the thing that contains them. So here, if we have person, we have connections for that person. These are the connections of that person. But you say, well, there are these connections in main. What are those? Well, if you wanted to have multiple mains, you could have it. I don't know what that would mean. I think it doesn't seem to be terribly meaningful. But it would be a lot more meaningful if we had cities. And those cities had connections, like roadways that connect them to other cities, right? If you had neighborhoods and neighborhoods that connect and have a proximity, that would make sense. Just as a general rule, it provides connections at all these different levels, because they're all just different types of agent types. I have trouble imagining when connections from any would ever be used. But it doesn't treat it as special. It just It just, okay, so don't use it then. It doesn't treat that in any special sort of way. It's just another agent type, and in this case, it's the main agent. It's the agent for the whole model, so it doesn't really make a lot of sense to do that. But that's a very important point, because it's easy to get confused. Especially easy to get confused because you forget to look at, what's up in that tab there, where it says main. You think you're working with person, you're actually working with main, and that's the confusion. Yes?
And just summarize this.
Sure.
So, in other words, you can say that you can create a sociogram and then create a different sociogram after each person.
Yep. That's correct.
Now, are you able to create the connections across those rows? So,
Yes, you can. Yeah. So I think. Yes, I can. It would be unusual to create a sociogram for main, because normally it's just one main. But like cities and person, you could create, and you could create a sociogram between those. You could say this person is associated with these cities, which are the cities that they visit to get boot camps or something like that, right? So I'm connected with Raleigh, LA, and Saskatoon, and Sydney, and Adelaide, and whatever, and Singapore, and those are the ones I go to for my boot camp, and so I might have connections between those, and a person would have connected with their dog as well as family members, usually in different networks. So yes, we can do that very readily, and we can have a given person associated with several types of networks. Does that help? Yeah, and those could be associated, and it could lead to presentation of sociograms of that sort. And moreover, a given sociogram, this is kind of implied in what I said, but I just want to make it explicit. A given sociogram could include agents of very different sorts. It could include agents in a nesting relationship, like the cities I go to or something like that. But it could also include, think of health practitioners, right? You have a sociogram associated with a healthcare team that involves a physiotherapist, an occupational therapist, MD, a social worker, etc. And those might all be in a sort of care team of relevance to a patient. Is that helpful? Okay. Other questions? This is great. Okay, so we've seen, ladies and gentlemen, our first network, and it should look something like this. Is there anyone who's not seeing it? Because this is kind of a fundamental gating point for our next step. This is a network. This network could be useful for many, many things in any logic. I did change the big population one to have a size of 1,000 rather than 10,000 because the network, well, among other things, the network is already very, very large. It's hard to kind of make sense of it. But we could zoom in. I'm doing Control mouse wheel here to zoom in and zoom out, and you can do that in general on any logic. You can also move around, pan the screen around to sort of see that with right clicking and holding. So I'm just holding down the right click button and going. I could also zoom into it and zoom out of it. Okay. So this is our little network. It's a distance-based network. It's one of many types of networks that we're going to be looking at. If people are comfortable with this, we're now going to go to the next stage where we're going to build on this by having people interact over the network. Okay? Are we ready? Okay. Okay, thank you. Great. Okay, so I'd like you to double click on person. And then what I'd like you to do is I'd like to create a state chart. This is going to be, and this is pursuant to Ben's question from yesterday, we're going to create an SEIR state chart, okay? So we're going to drag in a state chart here, and it's going to be, we're going to call it infection state chart, something like that, okay? So how did I do that? I went to palette, and then I went to state chart, and then I went to drag in state chart entry point. TAs should monitor all sectors for needs. Okay. Okay. And now I'd like you to drag in a state, and we're going to make it susceptible. susceptible. Yeah. And, we might think of this as, this is in no way privileging pathogen transmission. We might think of this as susceptibility to messaging. We might think of it as susceptibility to sort of ideas about safe eating practices or something. There's going to be a state exposed. This is actually a little bit more specialized, but I'm putting it in there for a reason. I'm putting in there to illustrate probabilistic transmission of attitudes, beliefs, or a pathogen. So I'm going to do exposed, and then I actually dragged in a transition betwixt the two that's going to be leaving hanging there, and I'm going to drag in a branch, okay? And then I'm going to drag in another transition from the lower side of that branch that goes to exposed, and another one that is going to go back to susceptible. And I'd like to drag it so it goes there. Okay, so we're introducing this new construct of this branch, okay? And I'd like to kind of work with this right now. So when we have this branch, it basically allows us to say, okay, with a certain probability, we'll do one thing versus another. So I'd like to actually make the default going back to susceptible, and this will be associated with a name that's like no transmission transition, and this will be by default. Okay, this will be by default that you stay susceptible, but with a certain probability, you're going to go on and become infected. Okay, Winchell, is that AV system picking up? It sounds like it is. Okay. Okay. So for this transition, going down here to exposed, that's only going to happen under a certain condition. This is going to be by default. We go back there. This one's going to happen only under a certain condition. And so this would be, we'll call it transmission. Maybe we'll just call it transmission rather than saying transmission, transition. Transmission. And the condition will be random true of 0.1. In other words, with 10% chance, we'll go down to this exposed state. Given we're exposed to this message or this pathogen, with 10% chance we'll go to, I say exposed, I'm going to call it latent, just to keep the semantics a little bit clear. So this represents exposure, and I'll call this the latent state, okay? This is kind of a state where someone's not yet actively acted on the message, or where the pathogen is sort of in an incubation phase where it hasn't yet led to development of infectivity. So this is a latent state, okay? That name is not too important, but okay, we're then going to add another one, which is infective. So here they're spreading themselves, spreading this this message to others, or they're spreading pathogen, and finally this is going to be a recovered state. Okay. Okay. Great. Okay. Wow. Let's now insert transitions between these. So latent to infective will be one transition, and as I'll call it, developing infectiousness, something like that, developing infectiousness, and then there'll be infective to recovered, okay? And this will be recovering, okay. Okay, so we've added a bunch of transitions. Now we're going to, for these latter two transitions, latent to infective, we will make it a certain timeout of 1. Sure, that's fine by default. And then For recovery, we're going to, well, maybe latent to infective, we'll make it a timeout of 3, like 3 days for flu. Latent to infective will be 3 days, okay? Sorry, this guy here, 3 days, and this guy here, infective to recovered, it will be 10 days, okay? 10 days. Here, we're going to make it a rate transition, though, and actually a rate of 0.1, so it's 10 days on average. So this one here, infective to recovered, will make it a rate with rate 0.1. So that means on average they'll remain 10 days in the infective state, but they'll have some chance of going sooner, some chance of going later, okay? So, 3. For this one here? Oh, this one. Good point. Oh, very good point. Thank you very much. This is going to be the kicker, okay? There's actually no timeout. It's going to be something else. And we're going to call this exposure. And it's going to be triggered not by a timeout, but by a message. A message that they get from somebody that's already so-called infective. Okay? So this is a message. This is where a message will come in, and with a certain probability, they'll actually, it'll stick. Otherwise, they just stay, it doesn't affect them. They'll just stay in this state. Okay, so ladies and gentlemen, I'd like to build this model. You can build it with this. Winchell, could you prepare for deployment? Okay, who needs Winchell help? Who needs TA help? Okay, okay. So, ladies and gentlemen, so I think what we'd like to do is one more step to show the colors. We want them to have a color according to the state that they're in. Okay. How would we do a color? Okay. Yeah. Oh, that was just a bulb. It just stays the same. Nothing changes. Okay. Maybe I'll go over that just for residual questions. I'm going to go through each of the transitions and show the assumptions. This transition here, the one for actual exposure, that's going to be based on a message. We just select message here, and nothing else changes. This transition, if they get exposed to that message, by default, nothing will happen. By default, it falls on stony ground. This transition here will occur with a 10% probability. That's what this random true is. Remember, where did we see this before, ladies and gentlemen? Where did we see that? Yeah, male and female. This is our way to flip a coin with a certain probability. It turns out heads. So here, they're going to go from here to here with a 10% probability. This is 0.9, it'd be 90% probability. So this is kind of their way of saying, okay, in this condition, if this condition is true, then we'll go from here to here. Otherwise, we'll just go back to susceptible. That's default. Okay? This next transition down, latent to infective, I did a timeout of 3 days, like for flu. You're often not sick for 3 days. You may be shedding after 2, but I've left it as 3 there. And then recovering will be a rate of 0.1. What that means is, on average, someone will be infected for 10 days. For some people leave before, some people leave after. It's memory. Each day you have a 10% chance of recovery. Sometimes it may take more than 10 days, sometimes less. Like almost like you're flipping a coin every day, but it's actually you're flipping a coin every second with a smaller probability. Okay. Even finer than a second. Okay. So anyway, since these are days, let's go up. Where do we set the time unit? Let's just go remember to set the time unit. Where do we do that? It's an aspect of the whole model, actually. So it's the whole model, and we're going to set the time unit to be days. Now, you may wonder, like, why does AnyLogic have months, weeks, years? Turns out AnyLogic actually keeps the detailed calendar, actually like days of the week and everything, and so you can set it, to distinguish weekend days from weekdays, and and keep track of leap years and all those sort of things. It's actually fairly sophisticated. And some models you'll actually see clocks and so on and things showing the date of the date of the year or what have you. Okay. Yes. Oh, like when we're running the model?
Yeah.
Oh, that's if, a great question. So when we're running a model, sometimes we want things to go as fast as possible. In which case we use virtual timer, we just set it and it tries to go as fast as it can. Other times we want it to go with a certain rate of speed because we want to see in detail what's going on, for example. We want it to play out in a way that if we're doing it to clinicians, that they recognize the behavior patterns, they can see kind of patients arriving and leaving. It's not going as fast as possible, and so we'll slow it down. And this virtual time mode means go as fast as you can. The sort of other mode means, will sort of, you can slow it and make it faster or slower as you see fit. Is that helpful? That'll be when we're running the model. Okay. Okay. Other questions? Great question. Okay. So, ladies and gentlemen, let's go here, and what we will do is we want it to set their color by their state that they're in. So how do we do that? You tell me. We're exercising these muscles. Sorry?
Click on the,
Good. This thing? Or
no, on
the,
chart.
oh, okay.
The state.
The state, yeah. And we could set colors. Okay, we can set colors, and we'll go ahead and do that. We'll make this yellow, make this, green, yellow, make this red, and then we'll make the recovered gray, okay? But is that going to actually change their appearance visually while we're running the model by itself? Not till any logic 8, probably. I'm working on it. But no, in order to do that, how would we make it so that they actually appear green while we're running it? If the, oh, yeah, okay, good. I like what I'm hearing. What do we need to do to change the color? We needed a variable called color. That's kind of their current color, and what should we make it for susceptible? Let's click on susceptible. For the entry action, what do we make the color? We make it green, okay? I labeled their color lime, so maybe I should make this green. Okay, there we go. Okay, for latent, oh, by the way, notice that I needed the semicolon. We're telling it to do something. Accomplish this task. Make it green. So we need that semicolon after it. Let me put that up on the big screen. After all, Hollywood is nearby. So there we go. Right? I don't think Hollywood would be interested in this movie, though. Okay, color equals green, right? Boot Camp, the movie. Okay, for latent, this will be yellow. For infective, this will be red. And for recovered, this will be gray. Spelled with A-A-Y, not E-Y. Oh, look at that. Oh, yeah, it's giving me trouble. Okay, so I just built it as I want, and it's giving me trouble. Why is it giving me trouble? Notice this type mismatch. Ladies and gentlemen, in Java, we have to watch our P's and Q's. And in this color, I should have said, by default, it's a double. It needs to be a what? A color. It needs to be other and a capital C LOR, just like that, with a capital C. Okay? So, in other words, this variable, we have to say, hey, this holds a color. It doesn't hold, 3.14159. It doesn't hold int like 0, 1, 2. It actually holds a color. Okay? And so we have to assign it. Okay, so here we assign these things, and now it should be a happy camper. Will this model work if I run it? right now?
Yeah.
Okay, what do I have to do still? What do I still have to do? What do I have to do still? So we assigned to this color, but does that color matter for anything right now? How do we make this color actually be the color of the person? What do we have to do? Sorry? We have to make the appearance of the circle here, right? The oval, the fill color be the color. Because otherwise this is just a variable. It says, oh, thank you very much, I'm green, I'm red, but it doesn't actually do anything. It doesn't make the color change at all, unless we tell this circle, hey, make your color this variable called color. Otherwise it's just a variable. It computes it happily, but it doesn't actually change something. Are people okay with that? Okay, okay, PA? So I think there's help. Who needs PA help? Who needs professor help? Okay, so I just set this to be color. Notice, folks, that you want, with this color variable, you want this to be color with a capital C. With this here, you want this to refer to the actual variable called color. This variable here. Okay? Okay, who needs help? Who needs help? The TA has entered the structure. Who needs help? Okay? Okay. Okay, so folks, this color here is something of, it's an example of a color with a capital C. That kind of denotes the set of all possible colors. And we're saying this color variable is going to hold a particular color. Here we assign it to green. Here we assign it to yellow. Here we assign it to red. Here to gray. And this circle here is set to be whatever the color is, its color will be as well. Okay, who needs TA help? They stand ready. They stand arrayed in a phalanx, ready to support you. Okay? Okay. That is, and it's because this says this color code variable is a specific example of this whole class of colors called color. This is actually a class. Just remember, we have like person. We define the person class, not define person, but define personness. What it means to be a person. So color with a capital C defines colorhood or colorness, and this is going to be a particular instance of colorhood, this color variable. So that's Java. That's Java for you. Yeah, that's helpful. If you define it, remember that option list we created, male and female, and we gave that a nice capital? Yeah. So there it would be with a capital. You'd use a capital for it. Okay. Are people okay? Who needs TA help? The TAs sit, ready for deployment. Okay. Okay, so here we go. So there's our model. So we had people, we had this thing so it could spread the message or the idea or the infection or the meme, but why is everyone staying in the susceptible state? There's no message. There's no message right now. Okay, so everyone's here and no one's leaving. Okay, so first of all, if they're infected, they should be spreading the message, right? They should be spreading the infection. How are we going to have that happen? Well, the one very easy way to do it in any logic, let's go to the infected state. And we here, right now, we can receive the message, but no one's sending it. So let's go to that state and let us go to the state chart and put in a transition here. And this will be a transition called contact. You notice it's going from this state to this state. How did I do that? Let me go delete that and we'll do it again. So I went over to the palette. Hey, come on. Went over to the palette here. I went down to state chart and I grab out the transition and I drag it there, okay? And now I'm going to set this to be contact, and I'd like to set the contact rate to be 10. It'll be 10. We're going to be people are going to be contact each infected person, each person in this kind of state they can spread the meme or spread the idea or spread the pathogen. We'll be contacting 10 people per unit time on average, okay? And so that's going to be a rate of 10, okay? And what's going to happen when they contact them? This is the kicker. And Ben came in for just the critical time. Ben, we added a connection and infective. We added color variable. We hitched that up per yesterday. And then we added this little connection. It's firing off at a rate of 10. And what happens there? Okay, folks, what we're going to do is this. We're going to call send. We're going to send a message. We're going to send the infection message, and the string is not particularly material. And we're going to send it. We're going to send it to a random connected person. Okay, I'm going to put this up on the board. This is in the action, and I'm going to put it up on the big screen here. Oops. And I'm going to make it a smaller thing so you can see it. Okay, this is what it is. So this is the action. I'm going to be sending a message. This message, actually, no one's particularly paying attention to what the contents of the message is. When they receive it up here, they don't really pay attention to the content. So that's not too important. You send the message, and to whom do you send it? Random connected. Now, this whole thing here, I actually didn't type that out. Here, let me show you what I did, and it'll spare you some grief. I just went here, I did comma, and I started to type random, control space, and I just selected this one. Boom. There you go. How did I do that again? Let's try that again. So I did this infection, and then I started to type random. I did control space. That's what gives me this thing here. Control space, and I clicked on this guy. Boom. And that's when it filled that out. So you don't have to go type that horrendous thing. This can be generated by control space once you've started typing random. Yeah. Yeah, there is. I really only use, I use this about 98% of the time. That's not quite true, 95% of the time. There's also random neighbor, which is to a neighbor in space, like someone next to you. And that's what was used in that other model, the very first model we examined. And then there's some other ones, like sent to everyone in the whole space or whatever. And that's, I almost never do that. Okay. Yeah, there is. Yeah. Yeah, there's quite extensive help on this. And you can go, if you go up here in this, I think, and you can type, random connected or something like that, or actually search for send would be a better one. Okay, it's doing it this time, so sorry. Okay, so message delivery type, but let me look up sending messages, and let's see, where would it be? Sending messages to specified recipients. This is to specified people or communication between agents. The question is, where would you send? Yes, I'm looking where you would find that particular list. On send, message passing, it may be here, messages. So, the answer is yes. It should be something which is very easy to find. I'm actually surprised it's not popping up right now, but, so if I searched under random connected, sorry? Oh, okay. Connected. This is this lists all of them, here, all connected, all neighbors, random connected neighbor. Yeah, I know. I'm trying to, exactly. So I would say, so you're saying this, Kurt? Communication, message routing rules, okay. Contact links, yeah, father, mother. I have a cheat sheet. Do you want it? Okay. Okay. I have a cheat sheet that I've created. Yeah, I could do that. I'll have to condense it. I've cheat sheets on these type of things, those sort of things scattered, and so I'll consolidate them and put it on there. Yeah. Okay. Wonderful. Right. Do they do that now or no? Oh, so tell me. You mean here, like this? Oh. Oh. Oh, wow. Nifty. Okay. So this is all we need. Okay, that's wonderful. I'm gonna, in my audience with them, I want to request so that you could have a button here and just, it would say, send to neighbors. You check that and it would do it for you, and so on. Okay, folks, so this is, thank you, TAs. That's, the phalanx has proven, its worthiness. So this is send to random connected infected. Thank you. That's great.
So while this clock is running on sending out this message, the clock for attempts to recovery is still going, right?
That's correct. Yeah, so this is a rate of 10, so 10 times a day, they're going to be sending these messages to people, which might involve imitative behavior, which might involve, pathogen, which might involve posts to blogs of ideas or what have you. And all through that, the time will be ticking down, so they're going to leave.
So for everything here, you have a transition.
Yeah.
And say you put, let's just simply think of it as a timeout rather than a break.
Sure.
Once you enter that state, and then you have say 3 or 4 or 5 transitions out of that.
Yeah.
All of the clocks
Are ticking.
start ticking.
That's right. But I want to, related to your question there, it's a very prescient question, because I want to distinguish this. This is important. I made this point yesterday, but it may not have sunk in. This is rather different than this. Oh, sorry. I had the same problem I had yesterday there. Here, they're actually leaving the state and coming back into it. And so actually all those timers are going to be reset then. But you actually need them to leave just stay within the state visually. I have some issues with that, but that's the way it is. Yeah. Okay. Well, you are asking the key question that I was going to pose to you. We were going to say, why isn't anyone getting infected? We have to send a very first message. Okay. And there's a couple ways we can do it. Let's take a vote. I could do it 2 different ways. We'll do it both ways. Who wants to see first? You click on an agent, and then that agent will get infected. The other option is we could send it to a random agent at first. That person will get infected. Who would rather do random agent? Okay, renovation. Okay, renovation meeting. Okay. Right. Okay, the one thing we're going to need to be careful about, because we have this exposed message, if we send a random message to a random agent, it might not make any difference. It won't sink in. We want someone to actually get infected. That's one of the sort of unpleasant. We actually want to force someone to get infected. Okay, great. So we're going to do this. So we actually want to spend a special message that will say, you get infected, for sure, okay? So first of all, they're going to be initially in what state here? What state are they going to be initially in? Oh, actually, I'll ask another question. This is another way to do it. How many people alternatively will want to start people in the infected state, a certain fraction of people in the infected state initially? That's also easy to do. That's the third way to do it. You want to do that? Start 1% of people in the infected state? Okay, let's do that. How would we do that based on my comments? This is a very common need in my modeling, at least, because we have a lot of data-rich modeling. How would we start 10% of the people in one state, 10% in another state? Suppose we want to start 10% infected. How do we do that? Have a branch. So let's go do that. Let's put a branch in place here. Boom. Boom. Right there. Okay. Here's a branch. And that branch is going to, by default, go to susceptible, but with a 10% or with a 5% chance it will go to infective. Let's prettify this. Let's click there. There we go. Double click there. Prettify it further. Okay. Okay. So here's our branch. By default, they go this way. With 10% chance they go this way. Tell me the code I should write. 10% chance they go this way. What do we do? Sorry? Random true. And we'll do it with, yeah, let's say 5% chance. Okay? Random true 0.05. We flip a coin, some of them start infected. Okay? Thank you. It's condition. Thank you, Kurt. Thank you, young man. Sorry, that's not in the action. Okay. Okay. So, sorry, this is not under action. So what am I doing? I'm the old man's having trouble. Okay, so it's condition here. Okay. So this is condition. Let me go over here. Okay? Good or not? Okay. Okay. Got it? Okay. So 10.5% chance to go this way. Shall we run it? Folks, shall we run it? Let us compute. Okay, so go to projects. Run this. Boom. Okay? Boom. Okay. Okay, the infection is spreading. The infection is spreading across the network. Okay. Okay, let's try that again. We're gonna do that again. Here are these people starting infected. I could speed this. Oh, TA help? Okay. TA. Okay. Okay. Yeah. Oh, okay. So if you drag it there, transition, drag over from there. You could just okay. Pull that one down to infected, and then this one just pull it up to anywhere on those guys. Fine. Yeah, that should be fine. Okay, now. Okay, now you can double click on this. Yeah, and then drag. Yeah, yeah. Okay, and then the key thing is you want this to be condition. and this should be random true 0.05. Let me get this on the board. So, this is what this is. Random true 0.05. Got it? Okay. Okay. Why don't you try and then make sure this guy says default. This guy, yeah, this one right here. Nope, the one going above just above that is transition. Yeah. That's exactly. Yep, that's good. Okay, try running it now. Okay. Okay.
I have the same question, so thank you.
Okay. Okay. Great. Okay. So we should be able to run it. And oh, okay. So maybe they're affected. Do you have a color thing? Let's go check. Maybe color if you close that. Yeah. And looks like you have color. So go up here. Is color set to set their color? So go click on that. Okay. So could you click on the border of it? Yeah. Okay. And then color. Okay, that's great. Okay, so go up to susceptible. This might be interesting. Oh, you need to set color equals green here. So color equal green. Yeah, excellent. Green. And the same thing, semicolon, the same thing for yellow, red, and red. Okay, who needs professor help? No, that didn't change. This is default, and this is condition. Oh, so condition. Okay, who needs professor help? Okay. Who wants me to show something on the screen? Who wants me to show something on the screen? Okay, from the model? No? No one? Okay. 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 Now, we started with 5% infected, and that leads to several sort of hubs of infection. If we really want to see this play out in greater detail, I'm tempted to change it to like 1% start infected or something, just so it's more obvious. So we'll make it 1% here. Boom. Sometimes it means no one will start. Sometimes it means 2 will start, but it will probably be more obvious if we have this. So okay, here's one hub of infection, and you can see it spreading out. Do you see that? Yeah. Okay. Now, I recognize most of you don't work in the area of infectious communicable disease. It's not a really big priority for many of you. But I hope you'll realize the generality of what we're seeing here. For a lot of conditions, a lot of risk factors for chronic disease, notably, influenced by other people is a very salient issue when it comes to imitative behavior, when it comes to transmission of norms, attitudes, beliefs, transmission of information passed through social networks. And here we have a very general mechanism whereby people could start in some initial state, they become exposed to some idea, meme, knowledge, attitude, some aspect of behavior, and they are influenced or they're not influenced. They go through a state of latency, which may be very short, it could be longer, and then they actually get in a situation where they're practicing that same attitude, knowledge, belief, or they're actually shedding pathogen, and at this point they're actually communicating it to others. And then, following some period of time, they may recover. Maybe this never goes on, in which case you could eliminate this component of it, or turn to a very long time cost. But here we have a situation where we have transmission going on of these effects in social networks. Okay, so no one started infected that time. Here one person starts infected, and it's transmitting over the networks, okay? And it's percolating across this network. So it's a pretty interesting feature of human context that can lead to very important types of dynamics. So, first of all, does anyone need TA help? That was a quite ambitious exercise, and I'd be glad to help anyone else get this running. Anyone? Sure. To random 1%. I just went to this. This is the condition that's undertaken when, for that exceptional case when someone starts infective, it leads them to start in the infective state, and it goes off with a 1% chance. Does that make sense? Okay. Yeah. Any other questions? No? Okay. Time is a ticking. So maybe what I'll do is very quickly go through, just looking what we got on the docket here. There we go. For this morning. Right. Good. We're doing actually pretty well. Okay. So I'd like to quickly go through with you. We're actually making up some time here, I think. Let's go through in the main class. I'd like to go through several other types of networks. Well, I tipped my hand already. Folks, what we have is a distance-based network right now. Two people are connected. If and only if their distance is within a certain, if they log within a certain distance from one another. Let's suppose we want to examine other types of networks. There's many types of networks to deal with. Scale-free networks is one of considerable interest. They exhibit preferential attachment. So they capture situations where certain people have lots and lots of connections, but most people have quite few. A fairly smaller number. There are also Poisson random networks and ring lattice networks and small world networks. Let's just go see the different networks that AnyLogic provides, and we can quickly cycle through them. We'll also examine the interactions of these sort of networks with layout types. Okay, so I have some additional things covered here, but I think we did a pretty good job with that. Let's go down now to the case of looking at networks. Boom, this is the networks transition, and I'm going to restart my recording. Boom. And let's go over to the recording and